Hi, welcome back to my channel pibyme Maths. This is by WST01. Here we are solving October-November 2022 Statistics 1 paper. In part 1 of this video, we have covered question number 1 to 4. So let's look at question number 5. The weights W grams of kiwi fruit grown on a farm are normally distributed with mean 80. So mu is 80. Sigma standard deviation is 8 grams. Okay. So we can write W follows normal distribution of mu comma sigma square. Now the table shows the classifications of the kiwi fruit by their weight, where K is a positive constant. So there are two categories. In small there are two categories. One is tiny, another one is petite. So if the weight of the fruit is less than 66 grams, that's considered a tiny fruit. If it's between 66 to 70, that's considered a petite. And then a large fruit, if it's between 70 grams or 80 grams, it's extra. 80 to K, we don't know the value of K, that's jumbo. If it's more than K, it's mega. That's how these fruits are categorized, okay? One kiwi fruit is selected at random from those grown on the farm. Find the probability that this kiwi fruit is a large. In order for this kiwi fruit to be large, the weight of the fruit should be more than 70, right? So we need to find P of W is greater than 70. So apply the standardize the normal distribution. Z is greater than X minus mu over sigma. You need to find this probability. That's basically minus 10 over 8. P of Z is greater than minus 1.25, which is same as the left hand side area of the positive number, positive 1.25. Just take the table value of 1.25. For 1.25, the value is 8944. So the answer is 0.8944. Leave it as it is. That's just a 3-mark question. Let's move on to part B now. 35% of the kiwi fruit are jumbo. Okay, let's look at the table. Jumbo means if it's between 80 to K, that's considered jumbo, right? So the question says 35% of the kiwi fruit are jumbo. I'm gonna just draw a bell curve here. We know the mean is 80. So this is 80. And then 60 below 66 is tiny. 66 to 70, so let's say 66 is here. This is considered tiny. 66 to 70, that's petite. And then 70 to 80, that's extra. Okay, 70 to 80, this is extra. And then 80 to K, we don't know the value of K. That's jumbo. And then more than K is considered mega fruit. This jumbo is 35%. That's what they are saying. 80 to K is 35%. So we know definitely, since the curve is symmetrical about the middle line, it's symmetrical about the middle line. So this is definitely 50%, right? And this one is 35%. So we can write P of W is less than K is equal to, that means everything on the left hand side of K is 85, 50 plus 35 is 85%. Correct? And using that we can find the value of K. Standardize this. Z is less than X minus mu over sigma is 0.85. Since 0.85 is a neat value, like a rounded figure, we change it to z is greater than k minus 80 over 8. The area on the right hand side of this will be 1 minus 0.85, right? Why we are doing that? Now we can use a small table to find the value of this corresponding to the probability 0.15. Look at the smaller table. For 0.15, the value is 1.0364. So 1.0364 is equal to k minus 80 over 8, and then make k as a subject. 1.0364 times 8 plus 80. They want the answer to one decimal place, so it's actually, I'm going to write the actual answer here, value here, 88.2912. Therefore, K is 88.3 grams. That's the answer. Let's look at part C now. 75% of tiny kiwi fruit weigh more than y grams. Okay, this is the tiny fruits actually. We don't know the percentage of this, but here in this tiny fruit, 75% of them weigh more than y grams. Find the value of y. Okay, so let's assume y is somewhere here. They say this is 75% of tiny fruits, not the whole 75%. So first of all, we need to find out the probability of this, the percentage of tiny fruits actually. That's basically the probability, right? So let's find that first. P of W is less than 66. We need to calculate this. Z is less than x minus mu over sigma. So that's going to be 68 minus 18 is 14 over 8. 1.75. P of Z is less than minus 1.75 will be same as P of Z is greater than positive 1.75. So how do we find this value? 1 minus P of Z is less than 1.75. To rearrange this, you should have learned how to apply standardize the normal distribution and find the area corresponding to a positive number, negative number or not. Okay, let's get the value from the table, subtract from 1. 1.75, 9599. 1 minus 0.9599, 0.0401. Okay, I'm going to explain this part now. Find how we are going to find the value of y. What is this 75%? So you need to pay attention closely. So I'll just draw a bigger diagram here, taking only the tiny part. Okay. $66 is here. I'm not taking the whole diagram. I'm taking only this part. This part. Okay. So here this area is 0.0401. That's what we calculated, right? 0.0401. Now 75% of this area, 75% of this weigh more than y grams. So let's say y is in here. This will be 75% of the total area. This will be 75%. This will be 25%, right? So if we take P of W is less than y means this will be 25% of the total area. So 25% of 0.0401. Standardize this. Y minus x minus 8, x minus mu by sigma is equal to get the value of this. 0.25 times 0.0401. Okay, 0.010025. Since the value is smaller than 0.5 and we are talking about left hand side area, definitely this is a negative number. So if we change it to positive number, we can write it as z is greater than 80 minus y over 8 is going to be the same. So what I'm going to do, if the right hand side area of a positive number is this, then the left hand side area of the positive number would be 1 minus this. 0.989975. So 80 minus y over 8 is equal to, I'm going to use a bigger table and look for the value 0.99 when you round it to decimal place, or 9899. We have 9898 here, that's the closest value, I guess. We have 989975. So in the table we have 9904. 2.32 is the closest value, so it's 2.32. Now make y as a subject. 2.32 times 8 and then minus 80. So y is equal to 61.44, round it to one decimal place. Therefore y is 61.4 grams. That's all. Let's look at question number 6 now. We have a Venn diagram given. Okay. Part A says write down the value of P of A. P of A is basically everything inside A. So it's 0.13 plus 0.12, 0.25. And double I, P of A given B is, A given B is P of A intersection B divided by P of B. That's a formula. P of B is from the figure, it's 0.12. A intersection B is basically P of B, right? You get 1 as the answer. And then triple I. P of A given C is P of A intersection C divided by P of C. There is no intersection between A and C because A and C are mutually exclusive, no intersection. So that the numerator is 0, so the whole thing is 0. Okay, part B now. Given that B complement intersection D complement is 7 over 10. B complement is everything outside B, D complement is everything outside D. So the intersection of these two will be this, this and this. So 0.13 plus P plus S is 7 over 10. So P plus S will be 0.7 minus 0.13. You'll get 0.57. Take it as equation 1. And then using this we frame the second equation. P of C intersection D divided by P of D is 3 over 5. C intersection D is Q divided by D is the whole thing inside D. Q plus R is 3 over 5. Okay. And then sum of all the probabilities will be equal to 1, right? So if you add everything, that's going to be our third equation. P plus Q plus R plus S is 1. So we'll get P plus Q plus R plus S is 1 minus 0.25, 0.75. When you sub in P plus S is equal to 0.57 here, you will get Q plus R is 0.75 minus 0.57, 0.18. Sub in this here, you get the value of Q already. Q divided by 0.18 is 3/5. So Q is 0.18 times 3/5. 0.108. See, that's how you need to use these equations to find the value of Q. Sub in Q back in here to find the value of R now. So R is going to be positive 0.072. Therefore, R is 0.072. That's all. It's a 6-mark question. You need to write the working properly. Part C, given also that B union C complement is this. So from the diagram, I'm going to put the diagram here. B union B is this. C complement is everything outside C. So this, and this. So 0.13 plus 0.12 plus R plus S is 5/8. So we know the value of R. So S is going to be 5/8 minus 0.25 minus R. The value of R is 0.072. 5/8 minus 0.25 minus 0.072, 0.303. That's the value of S. Question number 7 now. Adna selects one number at random from the distribution of X, which has the following probability distribution. Given that the number selected by Adna is not 5, write down the probability it is 0. Okay, they want you to find the probability of the number not equal to 5, which is basically it can be 0 or 10. So 0.1 plus 0.7 is 0.8. But if you read the question, we are missing a point actually. The question says, given that the number selected by Adna is not 5, so it can be 0 or 10. So the probability of not 5 is 0.8. But write down the probability that it is 0. She has chosen 0. It's like a conditional probability actually. So basically we need to find X is 0 given that X is not equal to 5. So on top we need to do X is 0 intersection X is not equal to 5, which is same as X is 0 divided by X is not equal to 5, which is 0.1 divided by 0.8 is 1/8. It's a conditional probability, but just a 1-mark question. Part B, show that E of X CAIE is this. The formula to find E of X CAIE is sigma X CAIE times P of X. So we need to square X and multiply by P of X and sum up. 0 square is 0 times 0.1. That's going to be 0 anyway. 5 square times 0.1, 0.2. 10 square times 0.7. Definitely you will get 75. 5 square is 25 times 0.2 plus 10 square times 0.7. 75 is the answer. That's all. Part C, find variance of X. The formula to find variance of X is E of X square minus E of X whole square. We know E of X square is 75 minus E of X square. E of X is, you need to take X and multiply by the probability. 5 times 0.2, 10 times 0.7. 5 times 0.2 plus 10 times 0.7, that's E of X and squaring. I'm gonna do everything one shot, or just calculate E of X first. The first one becomes 0. 5 times 0.2 plus 10 times 0.7. You get 8. 75 minus 8 square, 6 square, 64. 75 minus 64 is 11. Now for part D, variance of 4 minus 3x is, you ignore the number and the coefficient of x, right, squaring. Because the formula is this. If it's e of ax plus b, it's ae of x plus b. If it's variance of ax plus b, it's a square variance of x. You just ignore the number standing all along the b. So variance of x, which is 9 times 11 is 99, is the answer. Bruno and Charlie each independently select one number at random from the distribution of x. Okay, there are three numbers, 0, 5 and 10. They both get to select one number. Find the probability that the number Bruno selects is greater than the number Charlie selects. Okay, let's say Bruno takes all these numbers and Charlie also taking 0, 5, 10. But the question clearly says the number Bruno selects is greater than the number Charlie selects. So it has to be probability of, if Bruno chooses 0, that is the numbers are like bigger than 0, right? So he cannot take 0. He can take 5. Okay, I'm going to put it as B5. Bruno 5, Charlie 0. So the Bruno's number is bigger than Charlie's number. Plus probability of Bruno selects 10 or Charlie selects 0, or Bruno selects 10, Charlie selects 5, or probability of Bruno selects 10, Charlie 10. We cannot take this actually because they are equal. It clearly says that Bruno's number should be greater than Charlie's number. So these are all the three combinations. Okay. So for this, the probability of 0 is 0.1, and then for 5 is 0.2, this is 0.7. So it's going to be, for 5 it's 0.2 times 0.1 plus 0.7 times 0.1, 0.7 times 0.2. You will get the answer. 0.2 times 0.1 plus 0.7 times 0.1 plus 0.7 times 0.2. 0.23 is the answer. That's all. Now Devika multiplies Bruno's number by Charlie's number to obtain a product D. Determine the probability distribution of D. First of all, we need to find out what are the values that D, capital D takes. Okay, both of them get to choose a number, right? Bruno can take 0, 5 or 10. Charlie also can take 0, 5 or 10. So let's say they both are choosing 0, 0 or 0, 5 or 0, 10. What would be the product? When you multiply them, you'll get 0, 0, 0. Okay. Now Bruno chooses 5. Charlie chooses 0 or 5 or 10. It's another set of combination, right? And multiply them, because Devika multiplies both their numbers. So it's going to be 0, 5 5s are 25, 5 10s are 50. And then Bruno chooses 10. Charlie chooses 0, 5 or 10, and multiply them, you will get 0, 50, 100. So the multiplications, right? These are all the values capital D takes. So D takes, you can write this way, 0, 25, 50, 100. You don't need to write them in ascending order, but it's good if you write it in ascending order so that you won't miss out anything. These are all the values D takes. Now we need to find the corresponding probabilities. When D is 0, there are how many combinations you can see? 1, 2, 3, for 5 combinations: P of 0, 0, P of 5, 0, P of 10, 0, plus P of 0, 5, plus P of 0, 10. You need to find the probability of this actually. So we know the probability is corresponding to the numbers. For 0 it's 0.1, for 5 0.2, 0.7. So when you calculate this for 0, it's 0.1 times 0.1 plus 50, which is 0.2 times 0.1, but that appeared twice actually, right? So I'm gonna put it as times 2 plus, and then 10, 0 also appeared twice. So 0.1 times 0.7 times 2. Get 0.19. 0.19. The same way you need to find P of D is equal to 25 now. Okay, we are done with this, and this also. Now I am taking 25, that is only one combination. P of 5, 5 is 0.2 times 0.2 is 0.04. And then find D is equal to 50. We are done with 25. And for 50, there are 2 combinations: 5, 10, 10, 5. So P of 5, 10, P of 10, 5. It's basically 2 times 0.2 times 0.7. We'll get 0.28. So we are done with this also. And then the last one is 100. P of D is equal to 100 is P of 10, 10 is 0.7 times 0.7 is 0.49. You have to write them in a table. That's a probability distribution. You put small d, P of capital D is equal to small d. 0, 25, 50, 100. The corresponding probability is 0.19, 0.04, 0.28, 0.49. Whenever you draw a probability distribution table, you have to always make sure that sum of the probability should be equal to 1. So when you add them, you'll get 2, 3, 5, 1, 4, 9, 1. Total is 1, so it is correct. That's a 4-mark question.